Hello students. Today's class is regarding your Valence Bond Theory or VBT. In short form we can say that these are VBT or Valence Bond Theory. Okay. What about the conception of the theory? We have studied about your Warner's theory. The Warner's theory has stated regarding the structure of the complex initially, but it has not any directional property, or in detail it will not answer us regarding the structure, regarding the stability, regarding the magnetic behavior, or your coloring property of the complexes. So we should switch over into the next theory given by Linus Pauling, that is your Valence Bond Theory or VBT. So what about the conception? We will start point wise. The first point regarding the VBT is the Valence Bond Theory completely depends upon the methods or type of bonding between the vacant d orbitals and the central metal atom or ion. Again I am quoting the words like that. The Valence Bond Theory completely depends upon the methods or type of bonding between the vacant d orbitals of the central metal atom or ion and the filled orbitals of the ligands. So it is an interaction between the central metal atom, the vacant orbitals of the central metal atom and the filled orbitals of the ligands. Actually it is a coordinate bond or dative bond formation in between the donor atom of the ligand through its filled orbitals with the vacant orbitals of the central metal atom. Okay, so it can be represented like a arrow which is coming from the ligand and towards the central metal atom. So remind the one important point that this arrow will come from the ligand because the ligands are having the lone pair of electrons, and the central metal atom is having vacant d orbitals. So we can represent this central metal atom as M and ligand as L. So there is a bonding between the metal and ligand. Okay. So after the complete donation of the lone pair of electrons from the ligands orbitals to the vacant orbitals of the central metal ion, they will overlap with each another and will make ligand metal coordinate bond. Okay. So the second point should be for this to occur, the central metal atom or ion will make available vacant d orbitals at first to accept the lone pair of electrons from the ligands. What I am saying? I am saying for this to occur, that is the bonding between the ligand and the metal, the central metal atom or ion will make available vacant d orbitals at first to accept the lone pair of electrons from the ligands. Each orbitals can accept one lone pair of electrons from one ligand, and the number of vacant d orbitals will be always directed by the total numbers of ligands present in the complex compounds actually. So it is a very easy to understand this point that for this metal ligand bonding to occur, what is the central metal atom is doing? It is making available the vacant d orbitals at first to accept the lone pair of electrons from the ligand, or from the, we can say, from the donor atoms of the ligands. Each orbitals of the central metal atom can accept one lone pair of electrons from the ligand. Okay, we come to the third point. That is, if the central metal atom or ion is not having any vacant d orbitals. What I am saying, that the central metal atom or ion is not having any vacant d orbitals. What it will do, it will make available The point is very important. If the central metal atom or ion is not having any vacant d orbitals depending upon the total numbers of ligands present, then depending upon the strength of the ligands. So here we are quoting the strength of the ligands. It means we are having the category of the ligands like your strong field ligand and weak field ligand. Strong field ligand will pull the electrons of the central metal atom towards the inside, and your weak field ligand will make bond with the outer d orbital. We will come when we will discuss the structure of the complexes, but the point is very easy to memorize, that if the central metal atom or ion is not having any vacant your orbitals depending upon the total numbers of ligands present, then depending upon the strength of the ligands, the vacant d orbitals will be arranged by the central metal atom or ion. So this is the third point. We will come to the fourth point, a very important point. For making a bond between the lone pair of electrons or with the orbitals, that is the field orbitals of the ligand, the central metal atom or ion will hybridize their vacant orbitals at first, and so equalizes their energies and also makes the d orbitals directional, so that the ligand metal coordinate bond will be formed effectively and easily. Very, very important point of the coordination chemistry. That is, for making a bond between the lone pair of electrons or with the with the orbitals, field orbitals of the ligands, the central metal atom or ion will hybridize. That is the conception of hybridization. We have earlier studied the conception of hybridization in the chemical bonding chapter, where hybridization occurs, why hybridization occurs, what happens after the hybridization. I have already discussed all these things when I have taken the classes of your chemical bonding. So the conception, again I am repeating the conception, that is hybridization is a conception of remixing the outer orbitals of the central atom of a molecule. What is it? Remixing property of the outer orbitals of the central atom of a molecule, so that it will equalize the energies amongst those orbitals. So it is a process of remixing of the outer orbitals for equalization of the energies between them, and it will create a number of hybrid orbitals, and the number of hybrid orbitals which are formed, that will be equal to the number of mixing orbitals. What I mean, that if 4 numbers of atomic orbitals mixes up with each another, then 4 numbers of hybrid orbitals will be formed. So that conception will also apply over here also, that the central metal atom, depending on the number of ligand availability, it will hybridize the outer d orbitals, vacant d orbitals at first, and it will create a new mode of hybrid orbital, and then the hybrid orbital go for the overlapping of the orbitals with the ligand, and the ligand will donate, or it will make a coordinate bond with the lone pair of electrons with those vacant hybrid orbitals. Okay, so hybridization is one of the most important factor for this making of a coordinate bond. The fifth point is each and every ligands are having one orbitals which will have the lone pairs of electrons. What I mean, again I am repeating the same thing, that the ligands must have orbital which is containing the lone pair of electrons. Okay. The sixth point is depending upon the availability and mode of formation. What I am saying, depending upon the availability and mode of formation of the ligand metal bonding, the complexes will be named as inner orbital complexes or outer orbital complexes. For example, if any complex will make the bonding of the ligand and the d orbitals with their outer d orbital, it will be called as outer. if it is involving the inner d orbitals, it will be called as inner orbital complexes. So depending upon the mode of the formation, it will be named as so. And the last point, or the seventh point, is those complexes where there does not have any unpaired electrons. I'm saying the thing just to memorize it, that those complexes where there does not have any unpaired electrons in it, means they all are having paired electrons, then these are called as diamagnetic substances. It will not be attracted in the magnetic field. But on the other hand, those metal complexes which have one or more unpaired electrons, then it will be morely attracted in the magnetic field, and it should be then named as your paramagnetic or ferromagnetic or ferrimagnetic, and that it will be strongly attracted in the magnetic field. So these are the 7 points regarding your Valence Bond theory, and depending on that you should have the solution of the questions, particularly the structures of the complexes and the magnetic behaviors of the complexes. Even with the formation of the complexes, we will study the companion chemistry question and answer. Then if you are having any problem, you can ask me. Okay, bye.